Hey, this is Mark with Omni Embedded, and in this demonstration we're going to show you how quickly we can develop features using Vtrek. We're going to create a new project for an NXP K64 Freedom board, map 3 digital outputs to 3 LEDs on the board, create a new feature, and code the feature to flash the 3 colors at a 1-second rate. As far as LED control wiring, we're going to have our feature, which is LED Blinky. That's what we're adding. 3 data items in the data center, one for each LED. Those will be mapped through the digital output software component and will drive the pins that drives the LEDs. From a data center perspective, we're going to have write interfaces or writers to the Boolean data items in the data center. We're going to have those in the controlling feature, which is the one that we're implementing. We can also override those with the external tool. Within the data center itself, the RTI relationship with the data center means that we'll have on-change events at the digital output software component so that when the write occurs that changes a value of the Boolean, we automatically push that change into the hardware interface and out to the pin. So the first thing we need to do is set up a new project. I'm going to use Vtrek ProDev for that, but first I'll create a new folder for the project. Then I'll create the project using ProDev. Now I'll select the software components that we need from the Vtrek library, and in this case it's digital outputs. The DDC service will be used, but it's already enabled. Next I'll open the schematic so that we can map our digital outputs to the LEDs on the K64 Freedom board. Looks like it's port B22, B21, and E26, so let's map those. In the digital outputs, none have been mapped so far, so we'll start a new configuration array and give it a name. The task rate in this case tells us the maximum time it's going to take from when the data item is updated until it shows up on the pin. We need to enter the data item, and since we haven't created them yet, I'm going to go over to the data item menu and add all 3 for the 3 LED colors that we have. And I'm going to start a new group for the 3 LEDs. This group name allows us to filter the data items. When we try to view them, we can filter by group name. The bool is active high checkbox is used to correct the logic. So if we say true in code, meaning that we want something to turn on, the question is, does that mean that we need to put the pin high or low? And in this case, we need to put it low. That draws current through the LED and causes it to illuminate. So we're going to leave that box unchecked, meaning it's actually negative true logic, or when we say true, we want it to go low. The other 2 digital outputs for the other LEDs are configured in the same way. Now that configuration is complete, I've opened the project in Eclipse. And I'm going to show you the entries that the tool has made in the source code. So we'll take a look at the data item configuration file. And at the bottom, you'll see that we've added our LED Blinky group and the three LED booleans that you saw being created through the ProDev tool. So we're now going to create the feature source code files, and for that we need to create a new folder and then add that folder to the project configuration. Next, we'll create the source code files using the file templates. This one's going to be a singleton class. You can see from File Explorer that the two files, the .h and the .cpp, have been added to the project. If you look at the two source files, we can see that the file header and the various file sections have already been created, and the constructor is ready to be implemented. So now I'm going to use the the snippets tool to add some of the resources that we need in this file to blink LEDs. First, we're going to need a periodic thread function. We select the software component that we want this snippet to be added to, give the thread function a name, select a task from a predefined list of tasks. I'm going to set the task multiplier to 2 in this case, so we'll have 500 milliseconds times 2, or a 1-second thread rate, and I'll enable it in the constructor. The thread object was added as a member variable, and the thread function prototype has been added. In the CPP file, we see that the object was added to the constructor so that it's being created, and the thread function has also been shelled out. We also need to map the three data items, the LED data items in the data center, and so I'll use this snippet to do that, and we'll just do all three at once. So now we can see that getWrite interface or data item write interfaces have been added as member variables, and in the constructor we're doing a get interface to get them mapped to the data items. So I'm going to do a little bit of cleanup here. And then I'm going to add an enumerated constant for what amounts to a state machine that I'm going to put into the blink thread. There are a number of ways that this can be done. I'm going to go for simplicity for the purpose of this demo and just make it a state machine. So this thread, since we've set it to 500 millisecond task rate and a multiplier of 2, this thread is going to run every 1 second, which is what we want our blink rate to be. So what's going to happen is we're going to index through these 3 cases and then circle back and repeat in order to get our blink pattern that we want. You'll notice so far that the first actual code that's being written is in this blink thread. Everything else that's been put together so far for this demo has been done through the tool itself. So a lot of code was implemented and a lot of typing was avoided by using this tool. So we have a pattern now where we're writing to all 3 of these digital output pins in each of these states. So I can copy and paste that pattern and then just set each color true, and that should give us the pattern that we're looking for. Now I need to add routing to the state machine so that we go to the next state on every pass. And I've got the camera set up so that we can watch it at work once I've finished this and run it through the debugger. Alright, I've already got the debugger set up, so we're going to build the project and run it and see if we get the pattern that we're looking for. Okay, so we're getting our 3 color 1 second duration blink just as we wanted it. So let's just take a quick moment to review what we've done. We've used the tool to add most of the code in these two files. We've used the tool to add the file itself as well. The only real work that needed to be done was in the blink function. So we added an enum and a very simple state machine to run through and get this pattern. We've done this in pretty much record time. And hopefully this demonstrates the ease of going from a new project to having added, albeit a simple feature. It really didn't take very long to get this feature added. So thanks for your time, and I hope you'll visit us at omniembedded.com.